Good morning and welcome everyone for this diploma course on water resource engineering. Myself Santosh Kumar TR, lecturer, Civil Engineering Department, Government Polytechnic, Belur. In previous session of Unit 2 hydrology, you people have learnt about hydrologic cycle, forms and types of precipitation, and about measurement of rainfall by rain gauges. In this session, you will learn how to compute average rainfall of a catchment or a basin using the rain gauge readings. First, let's know what a catchment area is. It is the area surrounding the river from which water flows into it. See, you can see a catchment area here in the slide. This is the river and these are the tributaries of the river or streams. And this is the catchment area of the river. Whenever rainfall occurs in any part of this catchment area, it flows into the tributaries of the river or directly into the river. A catchment area of a river can be very big. For example, catchment area of Kaveri river is 81,155 km square and the catchment area of Ganga river is 8,61,404 km square. It's a huge area. So the rain gauge reading at one station in a basin may be different from that of a second station in the same basin. ಅಷ್ಟು ದೊಡ್ಡ ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾಲಿ ನಾವು ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಒಂದು ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ಒಂದು ರೀಡಿಂಗ್ ಇದ್ರೆ ಇನ್ನೊಂದು ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ ಅಲ್ಲಿ ರೀಡಿಂಗು ಬೇರೆ ಇದೆ ನೋಡಿ. ಯು ಕ್ಯಾನ್ ಸಿ ದಿಸ್ ಡಾಟ್ಸ್ ರೆಪ್ರೆಸೆಂಟ್ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಅಂಡ್ ದ ರೆಸ್ಪೆಕ್ಟಿವ್ ರೈನ್ ಗೇಜ್ ರೀಡಿಂಗ್ಸ್. ಯು ಕ್ಯಾನ್ ಸಿ ದೇ ಆರ್ ನಾಟ್ ಸೇಮ್ anywhere, they are different. So an average value of these rain gauge readings is worked out so as to get an idea of the average precipitation on the entire basin. ನಾವು ಇಡೀ ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾಗೆ ಒಂದು ಆವರೇಜ್ ಪ್ರೆಸಿಪಿಟೇಷನ್ ಎಷ್ಟಾಗಿದೆ ಅಂತ ನಾವು ಕಂಡುಹಿಡಿಯೋದಕ್ಕೆ ನಾವು ಏನು ಮಾಡಬೇಕಾಗುತ್ತೆ, ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ದಿಸ್ ರೈನ್ ಗೇಜ್ ರೀಡಿಂಗ್ಸ್ ನಾವು ವರ್ಕೌಟ್ ಮಾಡಬೇಕಾಗುತ್ತೆ. Before that, for average value to be accurate, we need to distribute this rain gauge uniformly over the catchment area. ನಮಗೆ ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಆಕ್ಯುರೇಟ್ ಆಗಿ ಬೇಕು ಅಂದರೆ ನಾವು ಫಸ್ಟ್ ಈ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ನ ಯೂನಿಫಾರ್ಮ್ಲಿ ನಾವು ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಮಾಡಿ. ಯೂನಿಫಾರ್ಮ್ಲಿ ಮೀನಿಂಗ್ rain gauge should not be placed only in places of heavy rainfall or in places of where rainfall is least. It should be properly balanced. ನಾವು ತುಂಬಾ ಮಳೆ ಬರುವಂತ ಜಾಗದಲ್ಲೇ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಇಟ್ಟು ಮಳೆ ಬರ್ದಲೇ ಇರೋಂಥ ಜಾಗದಲ್ಲಿ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಇಡಲಿಲ್ಲ ಅಂದ್ರೆ ನಮಗೆ ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಕರೆಕ್ಟ್ ಆಗಿ ಸಿಗೋದಿಲ್ಲ. ವಿ ಹ್ಯಾವ್ ಟು ಬ್ಯಾಲೆನ್ಸ್ ದಿ ಲೊಕೇಶನ್ ಆಫ್ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್. ಸೊ ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ is closer to accuracy. Now let's see how we can calculate the average rainfall using rain gauge readings. We have three methods for computation of average rainfall of a catchment area or a basin. See, these are the three methods. First one is arithmetic average method, second one is Thiessen's polygon method, and third one is isolated method. Let's start with arithmetic average method. See, in arithmetic average rainfall is calculated by averaging all the rain gauge readings recorded at various stations in the catchment area. In this method, we have to simply average all the rain gauge readings recorded at various stations. ಒಂದು ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾದಲ್ಲಿ ಎಲ್ಲೆಲ್ಲಿ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಇದೆ ಅದರದೆಲ್ಲ ರೈನ್ ಗೇಜ್ ರೀಡಿಂಗ್ಸ್ ನ ಕಲೆಕ್ಟ್ ಮಾಡಿ ಅದನ್ನ ನಾವು ಅದರದ್ದು ಆವರೇಜ್ ಕಂಡುಹಿಡಿದ್ರೆ ಆಯ್ತು. ದಿಸ್ ಇಸ್ ದಿ ಫಾರ್ಮುಲಾ ಫಾರ್ ಆವರೇಜ್ ರೈನ್ಫಾಲ್ ಆನ್ ದಿ ಕ್ಯಾಚ್ಮೆಂಟ್ by arithmetic average method. It's a simple formula. P is the average rainfall on the catchment and P1, P2, P3 are respective rain gauge readings at stations 1, 2, 3, 4 up till N. N is the total number of rain gauge stations. You have to add all the rain gauge readings and divide it by total number of rain gauge stations. You will get the average rainfall of the catchment. This is a simplest method and it gives approximate results. It won't give accurate results, it gives approximate results, but we can calculate average rainfall very easily and fastly. And this method gives satisfactory results only when rain gauge stations are uniformly distributed over the area and the rainfall rate does not differ much at various stations. ಅಂದರೆ ಈ ಮೆಥಡ್ನ ನಾವು ಯಾವಾಗ ಯೂಸ್ ಮಾಡಬೇಕು ಅಂದರೆ ಕ್ಯಾಚ್ಮೆಂಟ್ ಏರಿಯಾಲಿ ರೈನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಯೂನಿಫಾರ್ಮ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿದ್ದು ಮತ್ತೆ ರೈನ್ಫಾಲ್ ರೇಟ್ ಏನಿದೆ ಅದು ಒಂದು ಸ್ಟೇಷನ್ ಇನ್ನೊಂದು ಸ್ಟೇಷನ್ಗೆ ತುಂಬಾ ವೇರಿ ಆಗಿರಬಾರ್ದು. ಅಂತ ಕಂಡೀಷನ್ಸ್ ನಾವು ಈ ಮೆಥಡ್ ನಾವು ಸ್ಯಾಟಿಸ್ಫ್ಯಾಕ್ಟರಿ ಆಗಿ ಯೂಸ್ ಮಾಡೋದು. ನೆಕ್ಸ್ಟ್ we will discuss about Theson's polygon method. See, in arithmetic method, only rain gauge readings were considered for computation of average rainfall. But in Theson's polygon method, weightage is given for each rain gauge depending on the area it is assumed to be best representing. I'll repeat once more. In arithmetic method, only rain gauge readings were considered for computation of average rainfall. But in Theson's polygon method, weightage will be given for each rain gauge depending on the area it is assumed to be best represent. To find this area which the rain gauge represents the best, we have to collect the map of a catchment area. And see, this is the catchment area map. And we have to locate all the rain gauge stations. See, these are the rain gauge stations 1, 2, 3 and 4. Then what we have to do is we have to join the adjacent rain gauge stations by straight lines. We have to join the rain gauge stations by straight lines, and this what it does is it divides the total area of catchment into triangles. See, 1, 2, 4, 2, 4, 3, like this. The whole catchment area will be divided into triangles. Then what we have to do is we have to draw a perpendicular bisectors on each of these lines. We have to draw a perpendicular bisector on every line joining two rain gauge stations, like this. What these perpendicular bisectors does is they divide the whole catchment area into a series of polygons, each containing only one rain gauge station. See, you can see in the diagram here, the whole catchment area is divided into 4 polygons and each polygon contains one rain gauge station. And this rain gauge represents best this area. This area is best represented by this rain gauge, and this area A2 is best represented by rain gauge station 2. Here area it best represents means the rain gauge reading at a station matches to the actual rainfall that occurred throughout the surrounding polygonal area, and the polygon thus formed by the perpendicular bisector around a station encloses an area which is everywhere closer to the station than to any other station. I'll read once more. I'll tell once more. See, the polygon thus formed by the perpendicular bisector around a station encloses an area which is everywhere closer to that station than any other station. Means any point on this polygonal area is closer to this station than any other station. ಅಂದ್ರೆ ಈ ಏರಿಯಾ ಒಂದು ಈ ಪಾಲಿಗಾನಲ್ ಏರಿಯಾಲಿ ಯಾವುದೇ ಪಾಯಿಂಟ್ ನ ನೀವು ತಗೊಂಡ್ರೆ ಆ ಪಾಯಿಂಟ್ ಈ ಸ್ಟೇಷನ್ಗೆ ಹತ್ರ ಇರುತ್ತೆ, ಬೇರೆ ಸ್ಟೇಷನ್ಗೆಲ್ಲ ಹೋಲಿಸ್ಕೊಂಡ್ರೆ ಈ ಸ್ಟೇಷನ್ಗೆ ಅದು ಹತ್ರದಲ್ಲಿರ್ತದೆ. ಮತ್ತೆ ಈ ಏರಿಯಾದಲ್ಲಿ ಏನು ಮಳೆ ಬಂದಿದೆ ಆ ಮಳೆ ಈ ರೇನ್ ಗೇಜ್ ಅಲ್ಲಿ ಏನು ರೀಡಿಂಗ್ ಸಿಕ್ಕಿದೆ ಅದಕ್ಕೆ ಆಲ್ಮೋಸ್ಟ್ ಅದು ಮ್ಯಾಚ್ ಆಗುತ್ತೆ. ಅದರಿಂದ ದಿಸ್ ಇಸ್ ದಿ ಏರಿಯಾ which is best represented by this rain gauge. Like this, we have 4 rain gauge stations and 4 polygonal area respectively. To calculate average rainfall by Thiesen's polygon method, we have to multiply the area of each Thiessen polygon by rain gauge value of the enclosed station. We have to multiply area of this polygon, Thiesen's polygon, to the respective rain gauge station reading. See, this is the formula. P is the average rainfall, A1 is the area of the polygon, and P1 is the rain gauge reading or rainfall depth of the rain gauge station 1. We have to substitute all the values, and A is the total catchment area. If we substitute all the values and we will solve this, we will get the average rainfall. What we have to observe here is, see, I have told before what that we in Thiesen's polygon method, weightage is given for each rain gauge depending on the area it assumed to be to best represent. See, here the area of the polygons are different. Some have bigger area and some have smaller area. We are multiplying this area to the rain gauge station readings. If the area of the rain gauge station, polygonal area of the rain gauge station is big, the weightage of the rain gauge station in the formula gets increased. See, here A1 is slightly smaller than A2. A2 P2 or station 2 has more weightage in this formula for calculating average rainfall. See, this method is suitable where rainfall gauge stations are few compared to the size of catchment. ನಾವು ಈ ಮೆಥಡ್ನ ಎಲ್ಲಿ ಸೈಜ್ ಆಫ್ ಕ್ಯಾಚ್ಮೆಂಟ್ಗೆ ಹೋಲಿಸ್ಕೊಂಡ್ರೆ ನಂಬರ್ ಆಫ್ ರೇನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಕಡಿಮೆ ಇರುತ್ತೆ, ಅಲ್ಲಿ ನಾವು ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಅಥವಾ ಯು ಕ್ಯಾನ್ ಆಲ್ಸೋ ಸೇ ದಟ್ ವೇರ್ ರೇನ್ ಗೇಜ್ ಸ್ಟೇಷನ್ಸ್ ಆರ್ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟೆಡ್ ನಾನ್ ಯೂನಿಫಾರ್ಮ್ ಆಗಿ ಅಲ್ಲಿ ಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗಿರೋದಿಲ್ಲ, ಅಲ್ಲಿ ನಾವು ಏನು ಮಾಡ್ಬೋದು, ಇದನ್ನ ಯೂಸ್ ಮಾಡ್ಬೋದು. ಮತ್ತೆ ಇದು ದಿಸ್ ಗಿವ್ಸ್ ಬೆಟರ್ ರಿಸಲ್ಟ್ಸ್ ದ್ಯಾನ್ arithmetic average method. And these are some limitations of Thiesen's polygon method. See, in Thiesen's polygon method, a new Thiessen polygon diagram is required if there is any addition or deletion of any rain gauge station for the basic. ನೋಡಿ, ಈ Thiesen's polygon method ಅಲ್ಲಿ ಪ್ರತಿ ಸರಿ ಯಾವ್ದಾದ್ರು rain gauge station addition ಅಥವಾ deletion ಆದ್ರೆ ನಾವು ಪ್ರತಿ ಸರಿ ನಾವು ಒಂದು ಹೊಸ Thiessen polygon method ನಾವು polygon diagram ನಾವು ಬಿಡಿಸ್ಕೋಬೇಕಾಗುತ್ತೆ. ಮತ್ತೆ in this method no account is taken of the orographic features of the catchment. orographic features ಅಂದ್ರೆ ಅಲ್ಲಿ ಇರುವಂತ catchment ಅಲ್ಲಿ ಇರುವಂತ ಮೌಂಟೇನ್ಸ್ ಇರ್ಬೋದು, ಬೇರೆ ಟಾಲ್ ಸ್ಟ್ರಕ್ಚರ್ಸ್ ಇರ್ಬೋದು, ಅದರದ್ದು ನಾವು ರೈನ್ಫಾಲ್ ಹೇಗೆ ಎಫೆಕ್ಟ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ನಾವು ಇಲ್ಲಿ ಕನ್ಸಿಡರ್ ಮಾಡಿರೋದು Thiesen's ಮೆಥಡ್ ಅಲ್ಲಿ. ಮತ್ತೆ this method also does not consider the topographic features of the catchment. These are the limitations. Next we will see isohetal method. Before that, first we have to know what an isohet line is. See, an isohet line is a line on the rainfall map of the basin joining places of equal rainfall readings. See, in surveying, you people have learnt about contour lines. What is contour line? It is an imaginary line joining the points of equal elevation on a topographical map. If we join all the points of equal elevation in a map, we will get the contour line. In the same way, in a catchment area or in a rainfall map, if we join all the points of equal rainfall readings, we will get the isohet line. See, let's see how this isoid line is drawn or isoidal map is prepared. See, for that we need a catchment area map and rainfall record of various stations, and we need an experienced hydrologist who study all these rainfall records and the other topographical features of the catchment area, and he will draw the isohead line. See, in this picture you can see this is the catchment area and these dots are the rain gauge stations and these are the isohead lines. These are the isohead line values. This is the isohead line which is joining equal rainfall readings wherever 9 mm depth rainfall has occurred, it is joining those points. Likewise 10, 11, 12, 13, like that. In this method, we have to measure the area between the isohead lines, catchment area between the isohead lines, and multiply this area to average of the isohead line values. See, this is the expression or formula. Average rainfall P is equal to sum of area between two adjacent isoheads multiplied by average of the two adjacent isohead values, and this whole sum is divided by total catchment area. You can see here also. See, A1 is the area between isohead line 9 and 10. So P1 and P2 will be equal to 9 and 10. Likewise, we have to measure all these areas between the isohead lines and multiply it with by average of the two adjacent isohead values in between the areas in between which the area is present. A2, for A2 isohead line values will be 10 and 11. P2, P3 by 2. We have to average 10 and 11 and multiply it to A2. And this will be divided by catchment area, total catchment area. A1, A2, A3 are the different areas between the isohead lines. If we add all this, we will get the total catchment area. And the area enclosed between successive isohead lines are measured using planimeter. There is an equipment called planimeter. By that equipment, using that equipment, we can directly measure the area of this portion on map only directly. Similarly, we have to measure in Thiessen's polygon method also using planimeter. The polygon area will be measured using planimeter on the map directly. And this method gives accurate result, more accurate result than the other two methods. But there are some limitations to this method. The limitations are that we have to draw a new isohedral map every time for every rainfall, and the accuracy of isohedral map depends upon the experienced hydrologist. These are the three methods by which you can calculate or compute average rainfall of a catchment area. In next session, we will solve simple problems related to all these three methods. Before that, let's see what a mean annual rainfall is. See, the average of annual rainfalls of a station for over a period of 35 years is known as mean annual rainfall or normal annual rainfall of the given station. If we average annual rainfalls of a station recorded for over a period of 35 years. If we collect the data of 35 years of annual rainfalls of a station and then we average it, we will get the mean annual rainfall or normal annual rainfall. Why we need 35 years of rainfall records? Because rainfall varies day to day or monthly. It varies hugely. So to get an mean value, we need large number of years rainfall records. In India, we collect 35 years rainfall records to calculate mean annual rainfall. It is found that it has been found that 35 years rainfall records are required for a reliable estimate. If you want a reliable mean annual rainfall, we need 35 years of rainfall records. It does not mean that we just need 35 years rainfall records. If we have more than 35 years rainfall records, it gives more accuracy to the mean value. See, this mean annual rainfall is very important and it is required for planning and designing of any hydraulic structures or irrigation structures. Hydraulic or irrigation structures means dams, bridges or weirs, barrages, any structures that we construct to control flow of water in rivers or to store any structures related to water, we need this mean annual rainfall. See, using this mean annual rainfall, we can calculate index of wetness. See, the ratio of the actual rainfall in a given particular year at a given place to the mean annual rainfall of that place is known as index of wetness. If we divide actual rainfall in a given given year at a given place divided by mean annual rainfall of that place, we will get index of wetness. See, what this index of wetness indicates is it gives us an idea of the wetness of the year, and hence it indicates the deficiency of the rain. See, we'll see by example. See, 60% index of wetness means a rain deficiency of 40%. Means what it indicates is 60% of index of wetness means, see, actual rainfall is only 60% of mean annual rainfall. ಏನು ಮೀನ್ ಆನ್ಯುವಲ್ ರೈನ್ಫಾಲ್ ಇದೆ ಅದು 60% ಮಾತ್ರ ನಮಗೆ ಆ ವರ್ಷದಲ್ಲಿ ಮಳೆ ಆಗಿದೆ ಅಂತ ನಮಗೆ ಇದು ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ. ದಟ್ ಮೀನ್ಸ್ 40% ಇಸ್ ಡಿಫಿಷಿಯನ್ಸಿ, ಇನ್ನೊಂದು 40% ರೈನ್ಫಾಲ್ ಆಗಿಲ್ಲ. ಸಿ ಲೈಕ್ ದಟ್ ಎ ಡಿಫಿಷಿಯನ್ಸಿ ಆಫ್ ಅಬೌಟ್ 30 to 40% is known as large deficiency. If in a year we find deficiency of 30 to 40%, it is considered as large deficiency. And if the deficiency is 45 to 60%, it is considered as serious deficiency, and more than 60% as disastrous is considered as disastrous deficiency. By the index of wetness, what we can do is we can know how much deficiency of rainfall has occurred in the year. And one more term is there, that is we can describe a year with reference to mean annual rainfall as subnormal year or good year or an average year. See, the year in which the rainfall is less than mean annual rainfall is called bad or subnormal year. And if the rainfall in a given year is more than the mean value, then it is known as good year. And if the rainfall is in a particular year is approximately equal to the mean annual rainfall, then it is known as normal or an average year. ಯಾವ ವರ್ಷದಲ್ಲಿ ಮಳೆ ಮೀನ್ ರೈನ್ಫಾಲ್ ಗಿಂತ ಕಡಿಮೆ ಇರುತ್ತೆ ಅಂತ ಇಯರ್ ನಾವು ಬ್ಯಾಡ್ ಆರ್ ಸಬ್ನಾರ್ಮಲ್ ಇಯರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಯಾವ ವರ್ಷದಲ್ಲಿ ರೈನ್ಫಾಲು ಮೀನ್ ಆನ್ಯುವಲ್ ವ್ಯಾಲ್ಯೂಗಿಂತ ಜಾಸ್ತಿ ಇರ್ತದೆ ಅಂತದನ್ನು ನಾವು ಗುಡ್ ಇಯರ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಹಾಗೆ ಯಾವ ವರ್ಷದಲ್ಲಿ actual rainfall, mean annual rainfall ಸೇಮ್ ಆಲ್ಮೋಸ್ಟ್ ಅಷ್ಟೇ ಇರುತ್ತೆ ಅಂತ ಈ ವರ್ಷ ನಾವು ಹೇಳ್ತೀವಿ ನಾರ್ಮಲ್ ಆರ್ ಆನ್ ಆವರೇಜ್ ಇಯರ್ ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. And these are the references you can go through for detailed study. And these are some multiple choice questions that you can attend to assess yourself. To summarize this session, in this session, you people have learnt about how to compute an average rainfall of a catchment or a basin using all the three methods, that is arithmetic average method, Thiesen's polygon method and isoidal method. And you have also learnt about what is mean annual rainfall and index of wetness. Thank you and hope this was useful for enhancement of your knowledge. Thank you.